Hello and welcome to the first part of 5.9. We're going to begin with the problem of the day. So for the problem of the day, I would like you to find the slope and the y-intercept of each line. So pause the video and please complete this. So now the answers are posted here, and if you have any questions on how I got the solutions, you can pause and look at the work. But we have y equals negative 3x plus 2. And y equals negative 3x plus 27. Putting them into slope-intercept form helps me. I then can see that the slope of my first equation is negative 3, and the y-intercept of my first equation is positive 2. For my second equation, my slope is negative 3, and my y-intercept equals 27. So by putting them into slope-intercept form, we can easily determine our slope and our y-intercept. So now let's move into our lesson. Please take a moment and graph each of these lines. I'm going to start with the first one. I start with my intercept, so y equals 6, 2, 4, 6, and my slope is 1, rise 1, run 1, rise 1, run 1. And I can draw my line. My next equation has my starting point at 4, 1, 2, 3, 4, and it looks like I have the same slope, rise 1, run 1, rise 1, run 1, and I can connect my points. And my last equation has my starting point of negative 2, and my slope is 1 over 1, so I'm rising 1 and I'm running 1. And I draw my line and connect my points. Now when you look at these three lines, what do you notice is similar about them, and what do you notice is different? When I look at them, I'm noticing that they look parallel. These lines do not intersect. They could go on forever, and they would never intersect. I do notice that they all have different y-intercepts, so where they're passing the y-axis is different for each of them. So that is a difference. And when I look at my equation, I see that all my y's, my y-intercepts are all different. Another thing I'm noticing is that my slopes all look the same on my coordinate plane, and when I look at my equation, I see my lines all have a slope of 1. So it's interesting to note in this example that I have three lines all with the same slope but different y-intercepts, and the lines are all parallel. The conclusion I can draw from this is that lines with the same slope are parallel. So if I look at an equation and see that the slopes are the same, because it's the same slope, then I can determine that the lines are parallel. Looking at this example, we're being asked which lines are parallel. Knowing that lines with the same slope are parallel, I'm going to look for lines with the same slope. So for A, I see I have a slope of 3. Fortunately, these are all in y equals mx plus b, so I can quickly identify my slope. I'm going to look for another equation with 3 as the slope. B has 2 as a slope, C has 1/3 as a slope, and D has 2 as a slope. Therefore, there's no lines parallel. I'm going to look at equation B, and see I have a slope of 2. So for equation 3, 1/3 is my slope, but for equation D, I have 2 as a slope. So D and B are parallel because they both have a slope of 2. There's no relationship between A and C. So the answers would be B and D are parallel. Which of these lines are parallel? When I look at my examples here, I see that the first equation is written in standard form. The second equation is written in y equals mx plus b, and I can see my slope is negative 3/2. And my third equation is also written in standard form. So before I can proceed, I have to put these equations in y equals mx plus b, solving for y. So we'll start up here. I'll minus 6x from both sides, minus 6x from both sides. 4y equals negative 6x plus 12. I'm going to divide both sides by 4. Everybody gets divided. 4 equals, y equals negative 6/4 x plus 3. And this reduces down to y equals negative 3/2 x plus 3. So right here I see I have negative 3/2 as a slope. These two lines would be parallel. Let's look at our third equation. I'm going to subtract 2x, subtract 2x. 3y equals negative 2x plus 9. I'm going to divide by 3. I'm going to divide by 3. Y equals negative 2/3 x plus 9. If I look at the slope, negative 2/3, it is not the same as the other two equations. Therefore, this one is not parallel. And the answer would be 6x plus 4y equals 12 is parallel to y equals negative 3/2 x plus 5, because the slopes for each of these equations is identical. Now that we know that we can determine the slope of lines that are parallel, we can use this to write equations of lines involving parallel lines. What will be given is one point on a line and another line that is parallel, that it is parallel to. What we have to do is figure out what the y-intercept is algebraically, because as we noted in one of the previous slides, parallel lines have the same slope, but they have different y-intercepts. So let's take a look at this graph. The two lines are parallel. When you look at them, they're parallel. They have the same slope, so they have the same rise over run. So it looks like here if I rise up 2 and run 1, 2, 3, 4, that would be my slope. So rise 2, run 4, and that can reduce to 1/2. It looks like I probably could have picked this one up here as well. Let's test it out. If I rise 1 and run 2, I hit a point on the line, therefore the slopes are the same. What is different about them is they're passing through the y-intercept at different places. So if I know my slope and I have a point on the line, I can figure out different lines that could be parallel. From a parallel line, you may only take the slope. That's the only thing you're taking because the y-intercepts will be different. So what does this mean to us? Write an equation of a line with a y-intercept of 3 that is parallel to the line represented by the equation y equals 3x plus 7. Okay, so what do we know? We have a y-intercept and we have an equation. X, y, m, b. If the line is parallel, then I know it's going to have the same slope. So I see that the slope is 3. So parallel lines have the same slope. I can plug in my 3 for m. And they're telling me write an equation of a line with a y-intercept of 3. So the information they're giving me about the equation I'm writing is that the y-intercept is 3. So b equals 3. In order to write an equation, I need my m and I need my b. So I have what I need, and I can write it as y equals 3x plus 3. Here we have a little bit different information. Write an equation of a line which passes through point 4, 10 and is parallel to a line represented by the equation y equals 3x plus 8. So I will write down what I know. I know that parallel lines have the same slope, so I'm going to put a 3 for m because the slope is the same, 3. I've also been told that the line that I'm writing the equation for goes through 4, 10, so x is 4 and y is 10. What I don't know is my b. So I plug in what I know into my equation. Y equals mx plus b. 10 equals 3 times 4 plus b. 10 equals 12 plus b, minus 12, minus 12, b equals negative 2. So now I know that b is negative 2. I can go ahead and write my equation. Y equals 3x minus 2. So this is an introduction to how we start to write lines based on different information, and I will see you tomorrow in class. Thank you.